Good evening, sir. Good evening, sir.
Dasara.
Yeah, sir, you can start now, sir.
No vacation for Dasara, ma'am. Good evening. No vacation for Dasara, ma'am.
We'll be having, sir, from next week.
From next week, you make me the host, ma'am, not Ajay, madam. Now I'm the host. Thank you, ma'am. Good evening, Dhanlakshmi, Ajay, Dhanushri.
Good evening, sir.
Good evening, sir.
Good evening, good evening. Yeah. Yesterday, not yesterday, before yesterday, we did concentration cells. Right, one important question I forgot to teach you. I will teach you that question and then we'll come to the questions part. All right. Now we have learned the construction and working of Daniel cell in the beginning. Now we spoke about electrodes also. The electrodes are defined as metal dipped in its own ions is called as an electrode. We learned. Now for an example, if you take zinc ions and zinc rod is dipped in it, then it will be called as what? Zinc electrode. Likewise, copper rod and copper ions, copper electrode. Gold rod and gold ions, gold electrode. We learned it. Now, standard electrode potential, we learned electrode potential also. What do you mean by electrode potential? So potential developed when the metal is in contact with its own ions at equilibrium is called as what? Electrode potential.
Sir, electrode potential.
Yeah, it's called electrode potential. So if you measure at 298 Kelvin and 1 molar concentration, it will be called a standard electrode potential. So we learned about it. Nernst equation also I introduced, and we'll have to learn about Nernst equation, all that now in few minutes time. Now the important question is what you're going to learn. Now these electrodes are of two types. One will be called as primary reference electrode. We have reference electrodes. Primary reference electrode, and we have secondary reference electrode. So in order to measure the potential, we need to have a reference electrode. So primary reference electrode and secondary reference electrode. Example for primary reference electrode is hydrogen electrode. Example for primary reference electrode is hydrogen electrode. In modern days, we do not use hydrogen electrode because of its demerits. We will learn about the demerits of hydrogen electrode later. Now, secondary reference electrode, you should remember calomel electrode. Calomel electrode, silver chloride electrode. All these are examples for secondary electrode. Now, firstly, you understand this secondary electrodes, secondary reference electrodes will have a specific potential, will have specific potentials or specific voltages. So these secondary electrodes will have specific potential or specific voltage. Primary electrode, even though we have a specific voltage, we assume it to be what? Zero. That is one of the demerit of what? The reference electrode. See, hydrogen electrode is a primary reference electrode. There is some potential developed here, but we take it to be what? Zero. The electrode potential of hydrogen is taken as zero. Electrode potential of calomel is 0.242 volts. So calomel electrode is a secondary reference electrode. It has a specific voltage, standard voltage. But in case of hydrogen electrode, even there is some potential developed, we assume it to be 0 volts. That is the demerit of one of the demerit of what? Hydrogen electrode, or one of the demerit of primary reference electrode. We will learn about it a little later. What is electrode? Electrode is nothing but metal dipped in its what? Own ions is called as an electrode. So we learned electrode potential, standard electrode potential. We're talking about reference electrode. Reference electrodes are of two types. One is primary reference electrode, the other one is secondary reference electrode. Primary reference electrode, example is hydrogen electrode. And secondary reference electrode, it's calomel electrode, silver chloride electrode. Can you remember this?
Yes, sir.
Yeah. Now, others, can you remember?
Yes, sir.
Yeah. Now there is an important question which we have to learn for your 12th standard exam. We will learn that construction and working of the standard hydrogen electrode. Explain construction and working of standard hydrogen electrode. It is called as what? It's abbreviated as what? SHE. SHE. Standard hydrogen electrode. Explain the construction and working of standard hydrogen electrode. In order to construct the standard hydrogen electrode, we need to have a platinum foil, a thin sheet of platinum, a very thin sheet of platinum foil, very, very thin sheet of platinum. This platinum is fused to copper wire, just fused to copper wire through mercury, This is copper wire. It is fused through what? Mercury. It is fused to mercury. You have mercury here, little of mercury. Now, what's the statement I made? The first statement is this: platinum foil, a very, very thin sheet of platinum. All right, it's called as platinum foil. You know, aluminum foils. Food is wrapped in aluminum foil. You can see a very thin sheet of aluminum. It's not actually aluminum. They call it as aluminum foil. That's a different story. So a very thin sheet of platinum is called as platinum foil. This platinum foil is fused to copper wire through what? Mercury. Mercury is represented as what? Hg. Did you understand this? Did you understand the
Yes, sir.
statement? First statement. Right? Now, what's the first statement? Platinum foil is fused to copper wire through mercury. This is the first statement, first point. The second point is this copper wire is covered using a very thin glass tube. This copper wire is covered using a very thin glass tube. This red line, what we've drawn, is called as a very thin glass tube. Glass tube. Maybe we can write the second point. Copper wire is covered using a thin glass tube called as inner glass tube. Inner glass tube. The third point is this whole setup is enclosed or kept. This whole setup is enclosed in a glass jacket. In a glass jacket. The whole setup is enclosed in a glass jacket. And this glass jacket has minute pores at the bottom. This glass jacket has minute pores at the bottom. Not only this glass jacket has minute pores at the bottom, this glass jacket also has a provision to pass hydrogen gas. A provision to pass what gas? Hydrogen gas. Now, what's the next point? The whole setup is enclosed in an outer glass jacket, right, containing a provision to pass what gas? To pass
Hydrogen gas, sir.
Yeah, to pass hydrogen gas. And you have minute pores at the bottom. Now, whole of this setup is enclosed in a container containing acid. The whole of the setup is placed in a container containing what? Acid. All of this is placed in a container containing acid. The whole setup is placed in a container containing acid. Acid is represented as H+. Anything which gives H+ ions will be called as an acid. Do you understand the construction of this hydrogen electrode? What is the construction of hydrogen electrode? Platinum foil is fused to what? Copper wire through mercury. First point. Platinum foil is fused to copper wire through mercury. This copper wire is covered using a very thin glass tube called as inner glass tube. This whole of the setup is enclosed or kept in an outer glass jacket where you have a provision to pass what gas? Hydrogen gas. And we have what? Minute pores at the bottom. Minute pores at the bottom. And this whole setup is kept in a container containing what? Acid. This is the construction of the hydrogen electrode. Did you follow this? Students, you followed?
Yes, sir.
Yes, sir.
Yes. Yes. Now we need to understand the working of this. We need to understand the working of this. The working of this. Now what you have to do is you are passing hydrogen gas. When you pass hydrogen gas, this hydrogen gas gets absorbed on platinum foil. This hydrogen gas gets absorbed on what? Platinum foil. Now hydrogen gas which gets absorbed on platinum foil can undergo oxidation to form H+ ions, giving 2 electrons. So this hydrogen ion which gets absorbed on platinum can dissolve, undergoing oxidation. Or the H+ ions present in the acid can undergo reduction and gets deposited on platinum foil. 2 reactions are taking place. One is the hydrogen gas which is adsorbed, adsorbed on the platinum foil, can undergo oxidation, giving you 2 H+ ions and 2 electrons. Therefore, the H+ ions will dissolve. The hydrogen gas will dissolve in the acid. Or the H+ ions present here can undergo reduction and can get deposited on platinum. So that means it's a reversible reaction. So this is how a potential will be developed here. And that potential is assumed to be 0. We will learn about it later. This is the working of hydrogen gas, hydrogen electrode. Dry hydrogen gas is passed. This hydrogen gas gets adsorbed on platinum foil. So at the platinum foil, hydrogen can undergo either oxidation or reduction. Both it can undergo to form H+ ions and 2 electrons. This is the working of what? Hydrogen electrode. Did you understand the working?
Yes, sir.
Now the representation of hydrogen electrode. How do you represent a hydrogen electrode? So hydrogen electrode is represented like this. See, platinum is a support here. Platinum foil is a support here. This platinum foil, on the platinum foil, hydrogen gas gets absorbed. Adsorbed. And this hydrogen gas which is adsorbed on platinum foil is in contact with now what? H+ ion. Now this hydrogen gas is in contact with H+ ions, yes or no? Yes or no?
Yes, sir.
Therefore, we call this as what? Hydrogen electrode. See, any metal in contact with its own ions is called as what? An electrode. Here, a non-metal, hydrogen is also in contact with what? Hydrogen ion, using the support of platinum. Therefore, this is called as an hydrogen electrode. This is the cell representation. Now, what we have learned is hydrogen electrode. Now, they are talking about standard hydrogen electrode. When we say standard hydrogen electrode, what is the condition? The hydrogen gas what you are passing should be 1 atmospheric pressure. And the concentration of acid what we are taking is 1 molar. When the concentration of hydrogen gas is 1 atmospheric pressure and the concentration of hydrogen is 1 molar, and if this is measured at 298 Kelvin, then we call this as what? Standard hydrogen electrode. Hydrogen electrode at standard conditions will be called as what? Standard hydrogen electrode. Now, what's the standard condition? The standard condition is the pressure of hydrogen gas is what? 1 atmosphere, and the concentration of the acid is what? 1 molar. Then we call this as what? Standard hydrogen electrode. Did you understand?
Yes, sir.
I hope that you followed the standard hydrogen electrode construction and working and also the cell representation. Yes or no? Everything.
Yes, sir.
Now,
Yes, sir.
now we have to learn the demerits of hydrogen electrode. Before we learn the demerits of hydrogen electrode, we will learn the use of hydrogen electrode. Can I erase this? completely. Anyways, it will be there in the video. You can watch the videos. It's shared, no? Anytime you can watch the video. So I will erase this. Now, what is the use of this hydrogen electrode? Using the hydrogen electrode, we can determine the potentials of the unknown electrodes. We can determine the potentials of the unknown electrodes. What do you mean by that? You can determine the potential of the unknown electrode. Now just pay attention. Very simple. I'm going to teach you very fast. Now, to determine the electrode potential of the unknown electrode using standard hydrogen electrode. This is the question. How do we determine the electrode potential? This can be asked. Standard hydrogen electrode is important, and this also can be asked. What we're learning today is important. Now pay attention here. I have an unknown electrode here. When I say I have an unknown electrode here, it's a zinc electrode. I don't know the potential of zinc because I don't know the concentration of zinc ions. Since I don't know the concentration of zinc ions, I call this as an unknown electrode. This unknown electrode is connected to hydrogen electrode. Hydrogen electrode. See, the representation is different. This is the construction of hydrogen electrode. For simplicity, I have constructed like this. These two electrodes are connected externally by means of what? An insulated copper wire through voltmeter, and they are connected internally by means of a salt bridge. Did you follow this? The unknown,
Yes,
this is unknown, this is unknown, this is standard electrode. Standard electrode. So now this unknown electrode zinc is connected to the standard hydrogen electrode externally by means of a copper wire through a voltmeter, and internally by means of what? A salt bridge. That's all is the construction. Now, whatever is represented on the left side is called as anode. Whatever is on the right side will be called as cathode. At anode, what takes place? Oxidation takes place. At cathode, what takes place? Reduction takes place. No doubt about it. You know all this. So I'm not teaching you the cell reactions here. Now, EMF of the cell. E cell is calculated by the formula ERHE minus ELHE. Right hand side electrode minus left hand side electrode. Or electrode which is on the right hand side is called as cathode, minus electrode which is on the right hand side will be called as anode. Or electrode which undergoes a reduction minus electrode which undergoes oxidation. Cathode undergoes reduction, anode undergoes oxidation. So this is the EMF of the cell. Now what's the EMF of the cell? E cell will be equal to RHE. What's the electrode potential of hydrogen? The electrode potential of hydrogen is assumed to be what? 0. 0 volts. You should remember what is the electrode potential of hydrogen electrode, standard hydrogen electrode, they'll ask you. So it is assumed to be 0. It is 0 minus whatever you measure here. That's nothing but the electrode potential of what? Anode. Anode is zinc electrode. So what will be the E cell? E cell, whatever you measure, it's nothing but the potential of what? Zinc electrode. Did you understand? So because hydrogen electrode is taken as 0, whatever potential we measure, that will be because of what? The potential of what? The zinc electrode, unknown electrode. Did you follow this?
yes, sir. So,
Tell me.
so the potential of the hydrogen electrode will be 0 because it's a primary reference electrode, right? So,
Yeah, I didn't tell you the demerit. I will teach you the demerit in a few minutes time. Tell me.
yes.
What's the clarification? You tell me.
So that's it, sir.
Okay, I'll tell you I'll give you the demerits of hydrogen electrode a little later. Now, this is with respect to determination of electrode potential of unknown electrode, like what? Zinc. Now, if you take the unknown electrode to be copper, unknown electrode to be copper. See what happens. Left side becomes what? Hydrogen electrode. This becomes what? copper electrode. So hydrogen electrode is placed on the left-hand side and copper electrode is placed on the right-hand side. In case of copper, remember this. Now, what will be E cell? What will be this? Same, equation is same. But here, we can write E cell will be what now? E cell will be electrode potential of copper
So potential of the copper, sir.
minus electrode potential of what?
Yes, sir.
Hydrogen.
So hydrogen, sir, which will be 0.
Hydrogen.
So it will be
So-
positive of copper.
Positive value you will get. You will get what value? E cell will be what? Positive value. In case of zinc, E cell was negative value. Here you get what? E cell for copper as what? Positive value. Did you understand the difference?
Yes, sir.
Students, you followed or
Yes,
not?
sir.
Yes, sir.
Follow.
Yeah. Then Tanushri, by any chance you're there? You followed? All right. So construction and working of hydrogen electrode, determination of electrode potentials of hydrogen electrode using electrode potential of unknown electrodes using hydrogen electrode we learned. If they ask you to determine the electrode potential of zinc, remember zinc has to be placed on the left-hand side and hydrogen electrode will be on the right-hand side. If they ask you to determine the electrode potential of copper, then copper is placed on the left-hand side. Copper is placed on the right-hand side and hydrogen electrode is placed on the left-hand side. Now, what are the limitations of hydrogen electrode? Limitations of hydrogen electrode or demerits of hydrogen electrode. Firstly, electrode potential of hydrogen electrode is assumed to be 0. Assumed to be what volts? 0 volt. That itself an assumption. That is wrong because there will be some potential between the hydrogen and hydrogen ions here. So it is wrong. The second demerit is it is difficult to pass hydrogen gas at 1 atmosphere for a long time. Why in summer in the motorbikes, the vehicles, the air is filled lesser in summer? Why? Why? Motor vehicles, no, the wheels, the air is filled lesser, not up to the mark. Why? They fill it less in summer. Do you know or not? Okay, it is because in summer the temperature will be more, the gas will expand. That is why the blow is filled what? Lesser than the expected. Now it's fluctuating very drastically. Now when the temperature is fluctuating drastically, is it possible for us to maintain the pressure of hydrogen gas at 1 atmosphere for a long time? Temperature becomes cooler, becomes hotter. So what happened? Temperature is keep on fluctuating. Therefore, it is difficult
Pressure will also fluctuate, sir.
Yeah, pressure also will fluctuate. That is what it means. It is difficult to pass the hydrogen gas at 1 atmosphere for a long time. Third point, I told you when hydrogen gas is passed, some of the hydrogen gas gets absorbed by platinum. Some of the hydrogen gas can dissolve in water, dissolve in acid. When it dissolves in acid, it is difficult. It is difficult to maintain the concentration of acid 1 molar. Why it is difficult to maintain the concentration of acid 1 molar? Because hydrogen gas can dissolve in the acid. When hydrogen gas dissolves in the acid, the concentration of H plus will vary. When the concentration of H plus will vary, the concentration of the acid itself varies. It is difficult. Fourth point. It cannot be used. It cannot be used in the presence of oxidizing agents. In the presence of what? Oxidizing agents. Why we cannot use in the presence of oxidizing agent? Since we are passing hydrogen gas, if I use oxidizing agent, this hydrogen gas will oxidize to water. Therefore, we cannot use this in the presence of oxidizing agent like sulfuric acid or nitric acid. Only the acid what we'll be using is what? HCl here. We cannot use sulfuric acid nor what? Nitric acid, because the hydrogen gas will get what? Oxidized to water. Did you understand? These are the limitations of what? Hydrogen electrode. They can ask you limitations of hydrogen electrode itself for 2 marks. All right. So I've given you the 4 limitations or demerits of hydrogen electrode. I think it's easy to remember. First one is the electrode potential of hydrogen electrode is assumed to be what? 0. It is not truly 0. Second, it is difficult to pass hydrogen gas at 1 atmosphere for a long time because the temperature varies. Therefore, the pressure also will vary. And it's difficult to maintain the concentration of the acid 1 molar for a long time because hydrogen gas will dissolve in it. Some of the hydrogen gas will dissolve used in the presence of oxidizing agent because the hydrogen gas will get oxidized to water. So these are the demerits of hydrogen electrode. Is there any clarification till here? See, I'm taking time. I want you people to register this in your mind. This is an important question. So problems based on this will work later. Did you follow hydrogen electrode construction working? Any
Yes,
clarifications? Sir. Limitations also you followed? And to determine the electrode potential of the unknown electrodes using standard hydrogen electrode? Yes? Yes. Cell representation of standard hydrogen electrode you followed?
Yes, sir.
Yeah. What about Dhanalakshmi and Dhanushri?
Understood, sir.
Yeah, very good. See, others, nobody is, Dhanushri is not at all answering. Ajay, how many days is the vacation for you?
Sir, vacation, sir. Sir, till 10th, sir.
What's the program?
Sir.
What's the program? No response for that. Okay. If you keep quiet, I should not ask you then. I understand you, man. Very good.
Sir, no, sir, not like that, sir.
Concentrate on studies, all right? Little of time to spend in studies. All right, we'll learn some of the questions today, possibly. I have lots of questions to be dealt on this electrochemical cells. A few we will learn. And this is the competitive exam question. I will work the regular question for the PUC questions a little later, maybe after the end of the chapter. I told you last class also that I'll work some of the questions at the end of the chapter. Now, what material I've prepared? Since I'm not having time, I'm using the same material. Now I will give this other questions at the end of the topic. All right. Now, in Daniel's cell, the chemical energy is liberated during redox reaction, is converted to electrical energy. The electric energy of the cell is converted to chemical energy. The energy of the cell is utilized in the conduction of redox reaction. The potential energy of the cell is converted into electrical energy. What's that? Daniel's cell is an example for electrochemical cell. So in electrochemical cell, chemical energy is converted into what energy? Electrical energy. Chemical energy is converted into electrical energy. So the answer for first question is option A. So the answer for this question is option A. So the chemical energy is liberated during the redox reaction is converted into what energy? Electrical energy. All right. The next question. The following reaction are taking place in galvanic cell. Galvanic cell is an example for an electrochemical cell. Zn giving you Zn2 plus 2 electrons, and silver gaining an electron to form silver. Which of the given representation is correct method of depicting the cell? Which of the correct representation is correct method of depicting the cell. See here, we need to understand that anode is represented on the left side, cathode is represented on the right side, and both are separated by a parallel line, and this parallel line indicates it's salt bridge. I told you this. Right. Now, anode undergoes oxidation and cathode undergoes reduction. Now, for the reaction that taking place in the galvanic state, see here, zinc loses an electron to form Zn2+. That means zinc undergoes oxidation as per the equation. Silver accepts electron, therefore silver undergoes what? Reduction as per the equation. So zinc will undergo from Zn0 to Zn2+. The charge on zinc here is 0. Here the charge on Zn2+ is +2. Likewise, silver here from Ag+, it accepts an electron, it undergoes a reduction to what? Ag. Reduction to Ag. Now, this is a solid and this is aqueous. This is aqueous and this is a solid. This is solid. Now, these two electrodes are separated by a salt bridge. Therefore, the answer for this question is option A. Zinc undergoes oxidation from Zn0 to Zn2+. Silver from Ag+ to Ag0 reduction. Therefore, the answer for this question is option A. Did you follow this, students?
Yes, sir.
Yes, sir.
Yeah. The next question is the cell reaction of the galvanic cell is. Cell reaction they're asking. So copper solid undergoes oxidation to copper 2+. Mercury 2+ undergoes reduction to mercury and liquid. Now oxidation, I can write copper to copper 2+, CO2, CO2+. Where I say 2+, it gives you how many electrons? 2 electrons. And you can see here, mercury undergoes the reduction. That means this mercury 2+ accepts these 2 electrons and gets reduced to what? Mercury. Here the charge is 0. From +2 to 0, decrease in charge reduction. From 0 to +2, it's oxidation. Now, when you add these two equations, what happens? These 2 electrons and 2 electrons will get cancelled. So what do you have? Copper plus Hg2+, giving you Cu2+ plus Hg. Therefore, the answer for this question is option D. You can see here, copper plus Hg2+, giving you copper 2+ and Hg. Did you follow this?
Yes, sir.
Which of the following reaction is not possible at anode? Which of the following reaction is not possible at anode? At anode, what is taking place? Oxidation. What do you mean by oxidation? Loss of electron. See here, fluorine has a charge 0 and here has a fluorine charge -1. They're asking which of the following reaction is possible, they're asking. So 0 to -1, that means it's undergoing reduction. You can see here chromium, it's 3+, and here dichromate ion. Dichromate ion means what? Cr2O7 2-. What's the charge on chromium? As a whole, the charge is what? -2. It's ion, charge is -2. Oxygen valency is -2. -2 into 7 is -14. Chromium, we don't know, we take it as X. Since we have 2 chromium, 2X. So 2X will be equal to 12, X will be equal to +6. So oxidation state of chromium is +6 here. Here the chromium oxidation is +3, and here the chromium oxidation state is +6. Increase in charge is called as oxidation. So increase in charge is because of the loss of electrons. So this chromium 3+ will lose 3 electrons, therefore you get what? Chromium 6+. So this will take place at anode. Reduction, this is reduction. Here also you can see the charge on oxygen is 0. Here the charge on oxygen is -2. So this also is reduction. So at anode, only oxidation takes place. Therefore, the answer for this question is option A. Did you understand what I was talking so far? Yes?
Yes, sir.
Yeah. The next question. In the cell, ZnS/Zn2+ aqueous, salt bridge, copper 2+ aqueous and copper. The negative terminal is, what's the negative terminal? What's the negative terminal? Huh?
Sir,
Sir,
Zn.
this Zn2+.
No, it is only Zn. Electrode.
Yes.
Electrode. So negative terminal. Anode is a positive electrode represented by what sign? Negative sign. Copper is a negative electrode represented by what sign? Positive sign. Because here there will be loss of electron, therefore negative sign. Here will be gain of electron, therefore positive sign. That's all. Did you understand what I'm telling? This is the cell representation only in electrochemical cell. In electrolytic cell, this is not the representation. In electrolytic cell, anode will be represented as positive and cathode will be represented as negative. Only in the electrochemical cell, this representation. Now, for the galvanic cell, Cu2 plus, Cus plus, giving you Cu2 plus aqueous, salt bridge, Ag aqueous and Ag2S. Now tell me, read the options. Which is acting as cathode? The cell representation clearly says what is the left-hand side will be what? Anode. What is on the right-hand side will be what? Cathode. So copper acts as anode and silver acts as what? Cathode. It's directly given. The answer is what? Option? Not option A. It will be what? Option A. What's the question they're asking? For a galvanic cell, copper acts as anode and silver acts as cathode. That's true. Silver electrode loses mass and copper electrode gains mass. The reaction at anode is this: copper is more reactive than silver. All are true. The answer is all are true here. All are true here, but the specific question here, the specific answer expected here is not option A. All the answers is true. All the options are true, but here you can see copper will dissolve to form copper 2 plus ions. That means copper. No, this is wrong, man. The question itself is wrong. Question itself is wrong. No, copper will lose mass and silver will gain because at cathode deposition takes place. All right. So all see this is right and this is right and this is right. This is the wrong option. Maybe for a galvanic cell, maybe the question I have not written properly, I think. Which is wrong option, you should know. Which is the wrong option here? Wrong option. The wrong option is B. Copper loses what? Mass. Because copper is anode. At anode, oxidation takes place. Metal will dissolve. And silver is a cathode. Silver gains what? Mass. Gains mass. At cathode, what happens? Reduction takes place. Deposition will take place. So the wrong option is what option? The question is wrongly typed or incomplete question. Which is the wrong option here? So the wrong option is what? Option B. All right. I hope you followed what I'm telling, students. Yes or no?
Yes, sir.
Yes. Let us see now the next question. Oh my God. The standard EMF of a galvanic cell involving a cell reaction with N is equal to 2 is found to be 0.295 volt at 25 degrees Celsius. The equilibrium constant would be, they've given you the value of Faraday, they've given you the value of R. Remember, E cell is given by the formula Nernst equation we learned. E cell is equal to E naught minus 2.303 RT by NF log to the base 10 of K. They're asking equilibrium constant, remember. Equilibrium constant is represented as what? K. Now, at equilibrium, E cell will be equal to 0. This value is 0. E cell becomes equal to 0. When E cell becomes equal to 0, I can write the equation E naught is equal to 2.303 RT by NF log of K. Log to the base 10 of K. What is given? They've given you E naught to be 0.25. See the EMF they've given 0.25. No, E naught becomes 0. Sorry, this becomes 0. E naught cell, correct only. When E naught cell, no, not this. What I told is correct. This is E naught cell, correct. So what they've given is 0.295. that is equal to 2.303. R value 8.314. Temperature, they've given 25 degrees Celsius. 25 degrees Celsius is 298 Kelvin. N value, valency, they have given it as 2. And Faraday, they have given it as 96,500 into log K. They're asking us to find log K. So log K will be equal to, on cross multiplication, all that simplifying, all that, you will get log K to be 2.295 into 2 divided by 0.0591. Simplify this. You simplify the mathematical values. So this we will get it as 10. On simplification, this also will get it as 10. Log K is 10. So what will be K? K will be what? Anti-log of 10. Anti-log of 10 is 1 into 10 to the power 10. Anti-log of 10 is 1 into 10 to the power 10. Therefore, the answer for this question is option D. Look at this. The relationship between electrode potential or EMF of the cell and equilibrium constant. E cell is equal to E naught plus 2.303 RT by NF log K. So for the reaction which is at equilibrium, E cell is what? 0. Therefore, E naught cell will be equal to 2.303 RT by NF log K. So they've given all the values, substitution. Only thing is you should know how to find the anti-log. Or anti-log, you have to practice some of the techniques. I really forgot to teach you anti-log, and I really forgot how to work anti-log. Practice, because in the competitive exam, you will not be in log books to find the anti-log. You have to somehow learn the trick to find what the anti-log. But did you understand the substitution part of this?
Yes, sir.
Yes, sir.
The next question. The equilibrium constant of the reaction. The equilibrium constant of the reaction. They've given you CuS plus 2Ag plus aqueous, giving you Cu2 plus aqueous plus 2Ag solid. E naught is equal to 0.46 volt at 298 Kelvin. So they're asking you to calculate the equilibrium constant. Now, you should remember this relation also. These are for competitive. RT natural log of K is equal to NF E naught. RT temperature, gas constant, natural log of K. Natural log means log to the base E. Ln stands for log to the base E. Log stands for log to the base 10. So natural log means log to the base E is equal to NF E naught. N is valency, F is Faraday, E naught is the electrode potential. So natural log of K will be what now? NF E naught by RT. What is N? As per the equation, we understand copper, it is 0 here, it is 2. That means how many electrons is lost? 2. Valency is 2. Faraday, we know it is 96,500. E naught, they've given us 0.46. R value, we know it is 8.314. Temperature, they've given 298. So on simplification, natural log of K is, you will get natural log of K to be value itself you get, simplification, I don't know. So you get the K value as 3.68 into 10 to the power 15, 10 to the power 15. So approximating it, you get 4 into 10 to the power 15. 3.68 is close to 4. Therefore, the answer for this question is option C. Practice the mathematical part of it. Please practice. Used to you now for competitive exams. So they can ask you for PUC also. Maybe this question they can ask you for PUC, this question. But the 8th question, they will not ask for PUC. This question is not for your PUC level or 12th standard. The next question, all right. If the E cell of for a given reaction has a negative value, if E cell has a negative value, which of the following gives the correct relationship for the value of delta G and equilibrium constant? We should know that two relations I'm giving. Delta G naught is equal to minus NF E naught. The second equation is delta G naught is equal to minus EN RT natural log to the base 10 of K. So this is the relation between EMF of the cell and free energy. This is the relation between equilibrium constant and free energy. In the question, what they're given, each cell for a reaction as a negative value. That means this has a negative value. Which of the following gives the correct relationship for the values of delta G and delta E? Now, if E naught cell is negative, then delta G naught will be equal to what? Positive. See, if this value is negative and there's a minus sign, negative into negative becomes what? Positive. That's why we told delta G naught is what? Positive. When delta G naught is positive, it means delta G naught is greater than 0. Positive value 1, 2, 3 means it is what? Greater than 0. Now, similarly, if you observe, if delta G is positive, if delta G is positive, if this value is positive, now just see here, this is a negative value. So equilibrium constant will be what? Negative. When equilibrium constant is negative, it means equilibrium constant is what? Less than 1. Negative means what? Less than 0 is negative. So equilibrium constant will be less than 1. Hence the answer for this question is option A. Option B. Option A or B? B. Sorry. Option A. That is delta G is greater than 0 and equilibrium constant is less than 1. Did you follow this?
Yes, sir.
Yes, sir.
Yeah. The next question, the standard electrode potential E naught value for aluminum electrode. This is aluminum electrode. This is silver electrode. This is potassium electrode and chromium electrode are minus 1.66 volt, 0.80 volt, minus 2.93 volt, and minus 0.74 volt, respectively. The correct decreasing order of the reducing power of the metal. See, I missed out again a statement that's called as electrochemical series. What is this electrochemical series? Arrangement of electrodes according to increasing order of their potential is called as electrochemical series. What is electrochemical series? Arrangement of electrode according to increasing order of their potential. Now, for an example, we have lithium electrode. It is minus 2.76 volt. Aluminum electrode minus 1.66 volt. And zinc electrode, we have minus 0.76 volt. And whatever I'm remembering, I'm giving a hydrogen electrode, the potential is taken as 0. Copper electrode is plus 3.34 volt. Silver electrode is 0.80 volt, like this. So in the electrochemical series, hydrogen will be placed in the middle because it is 0. The electrode which is placed above all has negative value. They're all good oxidizing agent. And the electrode which is below, they're all what? Very good reducing agent. No, these all are very good reducing agent. And this is oxidizing agent. What do you mean by reducing agent? Reducing agent means which undergoes oxidation easily is called as reducing agent. Oxidizing agent means anything which undergoes reduction easily is called as oxidizing agent. So the electrode which is placed below hydrogen, they will undergo reduction easily. Therefore, they are called as oxidizing agent. Electrode which is placed above hydrogen, they will undergo oxidation easily. Therefore, they are called as reducing agent. I mean, did you follow this? Now the question is, electrochemical series is arrangement of electrode according to the increasing order of the potential. They're asking correct decreasing order of the reducing power. So lesser the potential will be greater reducing power. Which is having lesser potential? The lesser potential is for chromium. No, what is the lesser potential? What we have? Lesser potential. The answer, potassium, what's the potential? Potassium is this, minus 2.93, potassium. Next lesser potential is minus 1.66, aluminum. Third potential is what? Chromium. And the fourth is 0.80. So this is the fourth. Therefore, the answer for this question is option B. Did you follow this?
Yes, sir.
Yes.
Yes, sir.
Yes, sir.
Yeah, madam, I'll stop the class now, ma'am. I'll continue the class. Next, ma'am. Hello, ma'am. Because other topics are tough, and
Yes, sir.
I'll stop the class, ma'am.
Yes, sir. Yes, sir. Thank you, sir.
Thank you, ma'am.
Thanks, sir.
Yeah, bye.
Thank you, sir.
Bye.